Okay, so we're going to start talking about how to graph sine and cosine and how to change their graphs. So we're going to start that topic by talking about periodicity and then basic graph vocabulary. So what is periodic functions and what is a period of a function? So a function is periodic if there is a positive number p such that f of x plus p equals f of x, and for all of x in the domain of f. What that means is the period is how long it takes for a function to repeat. So the period of a function is just every period interval, the graph looks identical. So as you continue moving forwards or backwards on the x-axis of your graph, it looks like every other interval of the graph across the x-axis. And sine, cosine, and tangent are perfect periodic functions as an example because they're based off of a circle. So every time you go around the circle, you are repeating all of your values. So for sine and cosine, it takes them a full circle to go through all of their values before they start repeating. So we say the period of those functions is 2 pi if we're talking about radians, or 360 degrees if we're in degree mode. So they take the full circle to repeat. Tangent, on the other hand, is different. Tangent only takes half of a circle to repeat because it goes through all of its positive and negative combinations in the first two quadrants. So the period of tangent is pi, or 180 degrees. And we can use periodic functions to help us figure out values outside of our normal circle, which is what we're going to talk about now with the periodicity function, theorem, whatever. So if you have a periodic function and you are trying to evaluate it, all you have to do is work backwards or forwards till you're within that normal period. So with sine and cosine, we can add and subtract multiples of 2 pi or 360 to get us back within that 0 to 360, 0 to 2 pi first circle. And with tangent, we can add and subtract multiples of pi to get us back into the first period so we know what we're evaluating. So I know with all the words that's really confusing, so let's show you what it means with the numbers because it's actually pretty simple. So we want to evaluate the cosine of 2,670 degrees. Now that's a giant number, so we want to make it smaller. We want it to be between 0 and 360. So what I'm going to do first is I'm going to do 260 divided by 360. I'm sorry, 2670 divided by 360. It's early, having trouble with numbers apparently. Okay, so that's approximately 7.4. So that means I can take out 7 multiples of 360. So 7 times 360 is going to give us 2,520. So to find the cosine of 2,670, that's the same thing as finding the cosine of 2,670 minus 2,520. So when we do that subtraction, we are going to get that this is the same as the cosine of 150 degrees. Now since that's a unit circle angle, we know exactly what the answer is. That's negative root 3 over 2. Now say you didn't have a calculator and you couldn't divide 2,670 by 360 by hand. I mean, you should probably be able to do the long division anyway, but say you couldn't. All you'd have to do is it would keep subtracting 360 until you get a number that's less than 360. So you could do it that way as well. So we'll do example 2. So we want to find the sine of 15,780. Well, 15,780 divided by 360 is going to give us approximately 43.8. So that means I can take 43 whole multiples of 360 out of there. So we're going to do sine of 15,780 minus 43 times 360. Now 43 times 360 is 15,480. So we have 15,780 minus 15,480, which is going to give us the sine of 300 degrees. Okay, well 300 degrees is on the unit circle, that's in the fourth quadrant, and that's going to give us negative root 3 over 2 if we use our unit circle values. Okay, so let's do an example in radians. So now we have 17 pi over 4. The fraction line just didn't really show up. So we want to subtract off multiples of 2 pi to get back within there. So let's do this longhand with radians. So we have 17 pi over 4, and we want to subtract 2 pi over 1 from it. And we want to see what that does. Well, 2 pi over 1, I need to multiply the top and the bottom by 4 to get a common denominator. So this is going to turn into tangent of 17 pi over 4 minus 8 pi over 4. So if I subtract 8 pi from 17 pi, I get that this is the same thing as tangent of 9 pi over 4. But 9 pi over 4 is still bigger than 2 pi, because it's bigger than 8 pi over 4. So I'm going to subtract another 8 pi over 4, which is 2 pi. And we're going to get that this is the same thing as tangent of pi over 4. Well, tangent, remember, is just sine divided by cosine. Well, the sine at pi over 4 is root 2 over 2. The cosine at pi over 4 is root 2 over 2. Well, root 2 over 2 divided by itself just gives us a tangent value of 1. Okay, so let's get into graphs. So sometimes you might hear the word sinusoidal. So what a sinusoidal graph is it is a curve that is smooth and periodic. So that means it repeats. So basically it's a fancy word to refer to sine and cosine and tangent graphs. So it's graphs of nice waves that are smooth and repeat. So here is our basic graph of sine of x. So we're going to talk about some different qualities of it. So one thing to always take notice with sine and cosine graphs is where what we call your critical points are. So your critical points are on these points right here. So your critical points involve your maximums and your minimums.
Any teacher or para that needs to participate in the testing security makeup session will be meeting in the media center in about 7 minutes. Again, the testing security makeup session in the media center in about 7 minutes.
Sorry if you could just hear that school announcement. So our critical numbers are the maximums, the minimums, and the points in the middle. So those are our critical points that I just highlighted in black. So something else you want to take note of for sine and cosine graphs is because they're symmetrical, they have something called a midline. So right now for a normal sine graph, our midline is on top of the x-axis. It's directly in the middle of our graph. So we also have our midline. Another important feature of trig graphs is that they are periodic. They repeat. So you always want to know how long it takes to repeat. So one thing to notice is you want a full wave. So you want to get both a maximum and a minimum value in. So for sine, if you start at 0, we need to get 5 critical points in. So we have a critical point at 0. We have our maximum up here. Another critical point in the middle, our minimum, and then we end back on the same point where we started on. So this right here is the period of the graph. So for right now, it's 2 pi. You can also figure out the period by going from one maximum point to another maximum point. So if we look here, if we start at 5 pi over 2 and we go to pi over 2 over here, we want how far is it between those? Well, 5 pi over 2 minus pi over 2 would give us that interval. Well, that would be 4 pi over 2, which is the same thing as 2 pi. So that's another way to find your period, is to look for the distance between 2 maximum points or 2 minimum points. And one thing that the period can help us with is finding what we call the interval of the graph. So the interval refers to how far apart the critical values are. So you can always find the interval by taking your period and dividing it by 4. So for our sine example, our period was 2 pi, and we're going to divide that by 4. If we reduce that fraction, we get that our interval is pi over 2. And if you look, every pi over 2 is where one of our critical value happens. So those are the main features that we're going to talk about today. Oh, I forgot one actually. We also have something called amplitude. So amplitude, let's find a new color. So amplitude is the height from the midline to either the maximum or the minimum. So to find the amplitude, there's a couple of different ways you can do it. The amplitude is really the height of the wave. So you can either find where your midline is and then go however high up it is to the maximum, or however far down it is to the minimum, and that's your amplitude. Or you can take your maximum height, subtract your minimum height, and then divide it by 2. So in this case, for our example, our maximum height of the sine is 1. Our minimum height is -1. So we have 1 minus -1, which is going to give us 2. 2 over 2 is 1, so the amplitude of our graph is 1. So the main things we want to focus on right now are finding amplitude of graphs, finding where the midline of a graph is, finding the period, and then using that to find the interval. So we're going to look at some examples of some transformed sines and cosine graphs today. So we want to first identify if the graph below is sine or cosine, and then identify the amplitude, period, and vertical shift of the graph. The vertical shift is another way of saying where is the midline. So to figure out if it's sine or cosine, we're going to look at this point over here on the origin. So on the y-axis, we are not starting at a maximum point. So because we are starting at a middle point, that means we have to have sine. So because remember, so the sine graphs, the pattern goes on, above, on, below, on, whereas cosine starts above. So because we're starting on the midline, we have a sine graph. Okay, so let's figure out some things about this sine graph. So we want to figure out the amplitude, period, and vertical shift. So one thing that I always like to do is I always like to draw my midline onto the graph. So here's my midline. So my midline is up here at 3. So my vertical shift is going to be +3. Because we went up 3. Our amplitude is going to be the distance from our maximum point down to that height. So we go from 3 to 5, so our amplitude is 2. You can also figure that out by saying the max height is at 5, the minimum height is at 1. 5 minus 1 divided by 2 would give us 4 over 2, or 2. So there's another computation that you could do. And then we want to find the period of our graph. So the period is how long it takes to repeat. So I need to do an on, above, on, below, and an on point. That takes me from 0 to 2 pi, so our period is still 2 pi. Which would also tell me that the interval of this graph, how far apart the critical points are, is 2 pi over 4, or pi over 2. Okay, let's look at another one. So now we want to figure out again, sine or cosine, and then identify the different features. So if we look at our y-axis, we are starting up here. So that's a maximum of the curve. So because we are starting on a maximum, that tells me that we are starting a cosine graph, because we are starting with the above pattern. Okay, so again, let's draw our midline on. So if you can visualize it, that's great. So it looks to me like we are right here at our midline. So when I draw my midline, we are down at -1. So our vertical shift is -1. Okay, and then we want to find our amplitude. So our amplitude is the distance from a maximum point to the line, or from a minimum point to the line. So it looks like we're up here at -0.5 and down here at -1.5. So our midline was at -1, our max point is at -0.5, which means that our amplitude is 0.5. Okay, so now we need to find the period of our graph. So we're going to look for where we start and where we stop. So for cosine, we want to just follow our pattern. So we have an above, on, below, on, above. So here we have our 5 critical points, and it takes us from 0 to pi. So our period here is going to be pi. And our interval then is going to be pi over 4, because it's the period divided by 4. So that means that all of these critical values happen at pi over 4 intervals. Okay, so here's our last example before you're going to go and do your OU questions by yourselves. So last time, same questions. So again, to identify if it's sine or cosine, you look for what's happening on the y-axis. So on the y-axis, we are hitting at a middle point, which tells us that is a sine graph. So we're going to draw our middle line across the graph. So that's our midline, which will give us our vertical shift. So our vertical shift is up at 2, so we'll say it's positive 2. And then we want to find our amplitude, so we'll go from a maximum point down to the midline. So we're here at 2, our maximum is up here, it looks like 3.5. So the distance between 3.5 and 2 is going to be 1.5. And then let's look at the period of this graph. So we want to do all of our points. So let's do it differently just to show you another example. So I want to start here at my maximum, and the period is how long it takes me to get to another maximum. So I have one maximum at pi and another maximum at 5 pi. So my period, another way to find this out just other than visually, is I can say, okay, I have one maximum at 5 pi, and I need to know the distance from that to pi, so I subtract the two numbers. So my period is 4 pi. Which then tells me that the interval, the spacing of my graph, is going to be 4 pi over 4, or pi. So that tells me all of my critical values are pi units apart, which is true. We have 0. Our next critical point is at pi. Our next one's at 2 pi, 3 pi, 4 pi, and then we end back at 5 pi. So now you should have 3 OU graphs on the back of your worksheet. So you want to give those a try and identify if it's a sine or cosine graph, and then find the amplitude, midline, which is the vertical shift, period, and interval of those graphs.